अस्सलामुअलैकुम। आज सॉफ्टवेयर रिक्वायरमेंट्स इंजीनियरिंग का चौथा लेक्चर है और आज जो हम बातें करेंगे, वो जो टॉपिक्स डिस्कस करेंगे वो पहले 3 लेक्चर्स के ऊपर बेस बनाकर या पहले 3 लेक्चर्स का को फाउंडेशन के तौर पर लेकर आगे चलेंगे। तो आई थिंक इट वुड बी अप्रोप्रिएट to discuss what we had learned in the last 3 lectures. We had talked about requirements, what they are, and what is the importance of requirements in developing software products. And I think all of you would agree that requirements form the basis or foundation of the software product or products that one is building for the customers. So it is very important to gather requirements correctly and then continue on with different phases of the software life cycle. We also talked about 5 kinds of requirements. We talked about functional requirements, we talked about non-functional requirements, we talked about domain requirements, we talked about inverse requirements, and lastly we talked about design and implementation constraints which are captured as requirements within the requirements document. As the name suggests, functional requirements are those which describe the functionality of the software product. Non-functional requirements capture the emergent behavior of the software product. They are a very important part of the requirements model, although they are often overlooked. But you would agree with me that the importance that they have, that they must result in the allocation of proper resources and time to gather and categorize these non-functional requirements. They should be objectively and quantifiably measured, and we had discussed a set of metrics that can be used to measure the non-functional requirements. Then we talked about the importance of domain requirements. These are requirements which can either be functional or non-functional, but they come from the application domain that is under consideration. They are very important because they reflect the fundamentals of that application domain, and sometimes they are not clearly conveyed by the domain experts who consider them to be part of common knowledge of that application domain. But computer professionals are most likely not familiar with the common knowledge of that application domain unless they have invested some time in studying that domain or they have been working in that domain for some time. We also talked about inverse requirements. These requirements show that the customer is undecisive or indecisive about certain things and would like to state things in negative, which rule out certain possibilities. And it also shows that the positive side of the equation is not always clear. So there is a bit of indecisiveness on part of the customer when they are stating inverse requirements. And then we also talked about design and implementation constraints. These are constraints put on by the customer in application of software so that these constraints limit the scope of the designers in certain ways. We have taken an example of using, let's say, a .NET platform or using the object technology as a constraint Now, those constraints may be very legitimate from a business point of view, but they do put some constraints and restrict the choices available to designers and developers. And so these things are the foundation on the basis of which we will talk about requirements from another perspective. We will look at the requirements from users' perspective, and we will look at requirements from the system's perspective. So instead of looking at the kinds of requirements, we will look at the perspective of the user or the customer at the requirements model, and we'll also look at the system being developed, and we'll see what are the issues involved from those perspectives. And we will also discuss some of the problems that are associated with requirements. Now, these are not defects in requirements. These are problems that are associated with the requirements as a whole. So let's move on, and we'll talk about the viewpoint-oriented requirements. We can divide the requirements from two perspectives. Number one, from the user or the customer's perspective, or from the system or the contract's perspective. And then we will see what are the issues associated with each one of these views. So let's take the requirements from the user or the customer perspective. These can be functional as well as non-functional requirements. And typically a user would want to specify using a natural language such as English or Urdu or Japanese or Swedish or any other natural language with the help of some forms, with the help of some diagrams, because users do not speak computer languages. Users do not understand computer terminology. And I'm talking about most users. Some users do that, but in general, we can say that customers and users can think in terms of their own domains, and they can think in terms of the mother tongue or the natural language that is being used within their office environment. So they describe, that is the users or stakeholders, describe their needs from their perspective under certain constraints. They describe the expected services of the software product from their perspective in natural language. If we are in, let's say, Pakistan, we can either use the English language or we can use our national language, which is Urdu, to describe the needs, the functionalities, the expectations that a software product will fulfill, and they also describe the constraints attached to that product. These can clearly be defined as either functional or non-functional requirements. So the point that I'm trying to make here is that they require natural language as a medium of discussion. The next point that is very important from the customer perspective is that these requirements or services, a statement of services or constraints are understandable by the user, because users do not have technical knowledge in most cases. A user is only concerned with getting a requirement or getting a functionality fulfilled or getting a performance attribute or non-functional aspect of a product to be fulfilled. The user mostly are not aware of the technical details of the software product. So customers are mostly unaware of the technical details captured within the software product. So they state the requirements in such a way that they can understand, and you have to also appreciate the fact that the stakeholders are also at different levels of education and knowledge. There are end users, and there are domain experts, and there are business people, and there are managers. They all state requirements in their own terminology, which may differ from one stakeholder to another stakeholder. So this is another characteristic of requirements stated by the customer or by the user, that they capture some domain knowledge and some domain lingo which can differ among different stakeholders. However, these requirements should not contain overmuch technical discussion or constraints as far as how the software should be developed. This is important because, as I've said, there are different levels of stakeholders. Now, there may be computer professionals or professionals within the business area who have some computer knowledge, and they can use the computer terminology to convey their point of view to the developer side. And since the developer side understand the computer terminology, they may be impacted by this discussion. So it is the responsibility of the requirements engineers to filter out that computer terminology so that these requirements can be understood by a large set of stakeholders. Another issue that are associated with these user requirements is to eliminate detailed discussion about system requirements. When these system requirements are not discussed in detail, they can open the creative possibilities for the software designers and developers who are going to actually build the software product. The more detailed information about design and other constraints are put into the requirements model, the more the path of the designer's creativity are limited. And as a result, they may not be able to develop a software product as professionally as one would want to do it. And the situation can be avoided if unnecessary constraints, unnecessary detailed information is not included into the requirements model. Looking at the other concepts is that the software requirements stated by the users should be understandable not only to them but also to the requirements people and to the design people. This is important because whenever we are using natural language is subject to different interpretations, and we are emphasizing the fact that requirements should not contain too much details which limit the innovation and creativity of designers and developers in building the software product. But it does not mean that the requirements are vague and ambiguous. So care must also be given to the fact that the requirements that are coming from the user are not open to many interpretations, and they are not ambiguous, and they are not vague. Let's consider another very, very important part of the requirements that are coming from the user, and that has to deal with the rationale for the requirement. Now, as I have stated before, that there is a possibility that there are a number of stakeholders, and all of them are operating at a different level of understanding and hierarchy within the customer organization. And if it's a product which can be used by multiple customers, so you have these stakeholders which are sitting in possibly different parts of the world, and each is having a different concept or perspective on how they view the software product. So they may have preconceived notions about how the product should behave. And as a result, when they are providing or discussing requirements with the development organization or the requirements engineers, they choose to give their perspective to the requirements engineers. And as a result, you can see a conflict within these stakeholders, as we had talked previously in another lecture. But what is important is that rationale for each requirement should also be captured as much as possible. Now, whenever the requirements engineers are negotiating and performing an analysis of requirements, when the rationale is available to them, given by the users, given by the customers, they can easily come up with, or relatively easily come up with, the correct set of requirements to be included in the software product. The rationale also helps us in managing changes in requirements. A rationale is something which a user thinks why this requirement should be put into the software product in the first place. So rationale is a very important part of the requirement. It tells us the semantics of the requirements. It highlights on the need of the requirement, the reason why this should be included in the product. And that is a very important part as far as the user or the customer is concerned. Moving on, let's look at the system contract requirements. These are requirements which set out the services and constraints in detail. Compare these to the customer or user requirements, which describe the functional and the non-functional requirements of the software product without giving much detail. They describe the overall importance, the overall functionality, the overall non-functional aspects or the emergent character of the software product, but they do not provide, as far as the technical details are concerned, but these technical details are covered into the system or contract requirements. They may serve as the basis of contract for implementation of the system. These should be complete and consistent as much as possible. And we will talk about the completeness and the consistency aspect of requirements in a later lecture. But at this point, I would just like to say that if these requirements, that is the system requirements, inconsistent with each other or are partially documented, then there is a greater chance of failure of the software product, or a product which is not being used, or a product which is underutilized, or a product which is of no use to the customer who's paid for the development of the software. So the system contract requirements sets out the system services and constraints in detail. They may consist of formulas, they may consist of domain-specific situations. In the last lecture, I've talked about using the laws of physics and mechanics when we are considering the railway application system. Moving on to the next concept, the system contract requirements are used by the designers and developers as the starting point for system design. As you can see that these contract or system requirements are basically the starting aspects of the architecture of the software product that one is building. And they should be understood by the technical staff of the customer organization as well. And obviously, the development team has to fully understand the system and the contract requirements. They are for the designers and developers, and also for the testers who are going to then test the software product in detail. But if the customer has an IT department or has assigned this task to a third company or third party to negotiate these system contract requirements, then they must fully be understood by both parties, both the customer's representative as well as the development team, because the development team is then going to build software on the basis of these system and contract requirements. So in principle, these requirements should also state what the system should do. Now we are talking about system contract requirements. And in fact, all requirements should state what the system should do instead of how it should be done. However, we are talking about technical details, and I would admit that it is not always possible to omit some level of how in these requirements, because there are a lot of details that are included in the system contract requirements which are then used for the development of the software product. These requirements, which are the system requirements, can then be used as a starting point for development of the architecture of the software product. So it is not really possible to include some design information from being included in these requirements. But one must also give due care to the fact that these are requirements. These are not design artifacts. And one should be careful in not limiting the choices available to the designers and developers so that they are constrained very much in their creativity while developing this software product. As I had said before, that these system contracts can then be used to develop the initial architecture of the software product. This initial architecture can be very useful even at the initial phases of the software design. These requirements which form the foundation for the architecture can be grouped together. In many cases, our software products interoperate with each other, and that information must be conveyed to the developers and designers, and that is done through the system and contract requirements. And if we don't provide that information, then obviously our architecture will not interoperate with the existing products, and in the overall scheme of things, in the overall perspective of the businesses, our product would be a failure. Because I had probably said this before, that systems do not operate in vacuum. And with the importance of automation, companies and organizations are taking necessary steps to automate all their processes so that they can achieve higher levels of productivity, and human resources can be utilized in those areas where they are performing best, and these laborious computing-oriented tasks and repetitive tasks can be given to computers who can operate on them and work on them. The system contract requirements also include some design information or design constraints as external requirements. We talked about external requirements in lecture 2, and they are part of the non-functional requirements. So that information again is detailed information, and that information is specifically constraining the choices available to designers and developers. Natural language is used along with graphical notation to describe system and contract requirements. Natural language is also used to specify the requirements stated, or the user requirements or the customer requirements. But when we are specifying or describing system level requirements, we use modeling language also. Many specification languages have been developed as part of research in this area, which add structure to natural languages and clarify. This is important because natural languages are inherently ambiguous. There can be multiple meanings of words and phrases, and as a result, they can be misinterpreted by developers, and there can be a disagreement with the customer if only natural languages are used. So research in requirements engineering has resulted in the development of a large set of specification languages. But luckily, Unified Modeling Language has become the de facto standard in defining at least the object-oriented systems. And although UML, which stands for Unified Modeling Language, has been accepted as the modeling language of choice for describing different aspects of requirements, and as well as design and development and other phases, and is used in other phases of software lifecycle also. And all students are encouraged, actually required, to learn UML so that they can apply this in their projects and they can apply this in their professional lives. So, it's a good for our profession that there is agreement worldwide on using UML as applicable or describing requirements along with the natural languages. This discussion that we had up till this point today, we can look at requirements from two perspectives. We can look at requirements from the user or the customer's perspective, and we can also look at requirements from the contract perspective or from the systems perspective. These perspectives are important because they allow us to define or describe requirements in different levels. At the user level, we can define them using the natural language with the help of some diagrams, but the emphasis is on keeping these requirements at a level where the user can understand them. Again, the users mostly are not computer literate and they cannot understand technical computer languages, but they can understand natural languages and they can understand some graphical notations. If there is a disagreement on the understandability, they can be taught. The other level of describing requirements is the system level or the contract level. These requirements are also stated in natural language. However, they are stated with the help of one of the specification languages, and I had said that UML has become a de facto standard in specification languages, and it is being adopted the world over. The system requirements contain detailed information about the software product. They also contain constraints. They also contain external requirements, and they may also contain design and implementation limitations that are put on to the developers so that the products can interoperate with the existing products in the customer's environment. This pretty much sums up discussion on requirements that we have had up to this point. Now we will talk about some problems with the requirements. These are problems associated when we are gathering or analyzing or documenting requirements. Sometimes the requirements do not reflect the real needs of the customers. Why it happens? Because customers want something, and in some cases they do not need those things. Remember our discussion in lecture 1 when we talked about the difference between the word want and the word need, and both of these things are covered under the requirement. So in many cases one would see that the customer has a list of visual things or characteristics that they want included in the software product, but in fact they may not need it. So it is up to the developers and the requirements engineers to uncover or discover the actual needs of the customer so that unnecessary requirements are not included in the software product. The other problem with requirements is that they are inconsistent or incomplete. They can be inconsistent because they are coming from different stakeholders, and each one of them may have a different perspective. Each one of them may have a different influence in the on the developer's organization as well as within the customer. It is obvious that the people who are paying for the product or the manager level people have a higher impact on how things or what things should be included in the software product as compared to just users. But it may also be the fact that the requirements of the users have higher priority as far as the automation of that process is concerned, as far as the software product is concerned. So there may be inconsistencies within the software requirements model, and also requirements may be incomplete. They may be incomplete because some of the domain information has not been captured, or some of the stakeholders are not happy about the software product as a whole, and they may want to withhold some of the information that is necessary for the successful development of a high quality software product. It also has to be understood that it is expensive to make changes to software requirements once they have been agreed to, and once stakeholders have agreed to develop a requirement model, it may be expensive, and we will see in later lectures on why it is expensive to make changes to requirements which are included in the requirements model. Now, another problem associated with the requirements is that there are misunderstandings between customers and the developer side. There may be misunderstandings within the development team and the requirements engineers. And this has to do with the communication gaps, and this has to do with the level of, with what we call the gelness of the teams. If there is open communication lines between the customers and the developers, this problem can be overcome fairly easily. But if there is communication gap within the customer, or with the customer and the developer, or within the development team, then there can be very serious problems as far as the misunderstandings are concerned. And if there are misunderstandings, there are greater possibilities of misinterpretation of the requirements, and as a result, one can end up with a software product which is not the one which the customer would like to use. We also talked about the use of natural languages as a vehicle for the description or specification of requirements. Natural languages are, as I had said before, are the only medium available to the customer so that they can describe their needs and requirements to the developer. However, there are three basic problems that we face with the use of natural languages. Number one, it's the lack of clarity. Natural languages are inherently ambiguous. For example, I can use the word object. This word can mean a thing. This can also be used as a synonym for the word objective. And it depends on the context of the word and the phrase so that one can determine the exact meaning of that word or of that phrase. So there is lack of clarity as the number one source of problems as far as natural languages are concerned. Then there is requirements confusion. The second problem with using natural languages for documenting requirements is the requirements confusion. This means that the developers are not sure as to what kind of requirement this is. Is this a functional requirement, or is this a non-functional requirement, or is this a domain constraint, or is it a design constraint? And this is a problem that requirements writers have to overcome and clearly state their requirements. Now, it may be possible to confuse these requirements or different kinds of requirements, because there may be some domains in which it is possible to confuse these things. But if the requirements engineers are aware of the application domains and they have some basic knowledge about the workings of the application domain, then they can overcome this problem. The third problem with using natural languages is requirements amalgamation. That is, mixing different kinds of requirements together. People tend to describe things together, and if the requirements are described together, they may result in confusion and they may result in problems for developers and designers of the software product. Now, it may be considered a very artistic activity to describe multiple things in one sentence, but as far as the requirements for the software products are concerned, they can cause a lot of confusion and problems for the designers and developers of the software product. So one should avoid this tendency to include multiple requirements of pertaining to a software product in one requirement. Another problem that happens with this is that not only multiple requirements are described together, but they are of different kinds. So in one sentence, one can find multiple functional requirements and maybe one or two non-functional requirements, and an underlying concept of domain requirements are also mentioned, which makes it very difficult then to clearly understand what is the intent of the requirement. And once you have that situation, it is possible to misinterpret these requirements or to develop a system which is not the intent of the customer. The problem with these natural languages is that we use words and phrases to convey meanings. Now, if a reader and a writer agrees on the meaning of a word or a phrase, then that concept is conveyed. If a reader and a writer takes different meanings for these words and phrases, then the meaning is lost. And that is the biggest underlying problem with the natural languages. So it is up to the readers and writers to convey and understand these meanings respectively. So that is why we have lack of clarity and requirements confusions and other things. Another problem with using natural languages is that natural languages are over flexible in specifications. One can say one thing in multiple ways, and that is situation dependent. And it then becomes very difficult to understand that this concept was conveyed in this terminology in one place, and the same concept may be conveyed in using another terminology in a different place. And now, as far as the language is concerned, this is a very beautiful concept that one can convey meanings in multiple phrases in different contexts, and one doesn't get bored. But as far as these technical documents like requirements documents are concerned, this is a problem for requirements engineers as well as software designers and developers, because they then have to relate these contexts, and it is not fairly easy to do that because these designers are technical people, and to relate two different contexts in a large set of requirements is not always easy. So another problem that we have discussed with reference to usage of natural languages for specification of requirements is the fact that natural languages are over-flexible in specification, and things can be conveyed in multiple ways using different terminologies, but this is a problem as far as documentation and specification of requirements is concerned. We'll take up another set of issues now. It is not possible to modularize natural language requirements. By that I mean it is not possible to contain the requirements in one location if we are using natural languages. Modularization is a concept which is very well understood by students of computer science and professionals. This is how we develop our systems. This is how we deal with complexity. And it is not possible to apply this concept to natural languages. Now, if we don't do that and we have to make a change and we have to relate requirements so that we can understand the consequences of a change on the requirements that are associated with each other, we have to search the entire requirements document. Now, it is possible to put related requirements together, but this is a classification on the part of the requirements engineers. The language does not provide us any support with respect to modularizing these requirements. That is, let's consider English language. There is no limit or no constraint on the writers of the language that say that you can only describe similar concepts in one place. And that is a problem of not being able to modularize requirements when you're using the natural languages. The requirements engineers may do it themselves. They can classify and categorize requirements and document them so that they come together in the requirements document. But the language tool, the tool that is the English language or any other natural language for that matter, does not restrict them in putting them together. But if you're using any of the other languages like UML, they have a specific meaning for specific things, and modularization is fairly easy to do in those languages. Continuing our discussion on this, let's consider the impact of natural languages. I had given an example just a few minutes ago about using the word object. One meaning that I did not give at that time was the meaning of negative to the object. You can take anything, let's take a pen, and that is an object. And we can say the objective of this research is to find possibilities of developing this road network. That is a word object. And then you also have the I object to your point of view. तो इस मिसाल में हमने देखा कि तीन सिचुएशंस में एक ही लफ्ज़ तीन मुख्तलिफ तरह से इस्तेमाल हुआ है, और अगर ऐसी सिचुएशन हमारे पास रिक्वायरमेंट्स डॉक्यूमेंट में हो तो डिज़ाइनर्स और डेवलपर्स के लिए ना सिर्फ कंफ्यूजन है बल्कि उनकी अपनी इंटरप्रिटेशन के ऊपर सॉफ्टवेयर प्रोडक्ट के अंदर वो डिसीजन ले सकते हैं. और अगर ऐसी सिचुएशन हो कि डिज़ाइनर का इंटरप्रिटेशन कस्टमर के इंटरप्रिटेशन से मुख्तलिफ हो जाए तो जो प्रोडक्ट बनेगी वो कस्टमर की नीड्स से मुतसादिम होगी और हम उसको एक फेल्ड प्रोडक्ट कह सकते हैं. तो ये बहुत अहम बात है कि हम जो प्रॉब्लम्स हमें आती हैं रिक्वायरमेंट्स में उनको एड्रेस करें, और सबसे ज़्यादा जो प्रॉब्लम आती है वो इनकन्सिस्टेंसी और इनकम्प्लीटनेस की होती है, और ये इसलिए होती हैं कि ये ज़्यादातर हम नेचुरल लैंग्वेजेस को रिक्वायरमेंट्स कैप्चर के लिए यूज़ करते हैं. और उनकी जो प्रॉब्लम्स हैं नेचुरल लैंग्वेजेस को यूज़ करने की, वो आपके साथ आज डिस्कस हुई हैं। उसमें पहले नंबर पर लैक ऑफ क्लैरिटी है, फिर रिक्वायरमेंट्स कन्फ्यूजन है, उसके बाद रिक्वायरमेंट्स अमेलगमेशन है। क्लैरिटी के अंदर रिक्वायरमेंट्स क्लियरली स्टेटेड नहीं होती। बहुत दफ़ा कस्टमर को भी अपनी रिक्वायरमेंट्स का नहीं पता होता, जैसा कि हमने पहले भी देखा था कि जो इनडिसाइसिव नेचर है कस्टमर की, वो बाज़ जगह पर बाज़ रिक्वायरमेंट्स में रिफ्लेक्ट होती है। और कन्फ्यूजन में ये है कि बहुत सारी अक़साम जो हैं रिक्वायरमेंट्स की, वो इकट्ठे या बहुत सारी जो रिक्वायरमेंट्स की अक़साम हैं, वो पता नहीं लगता कि ये फंक्शन रिक्वायरमेंट्स हैं या ये नॉन फंक्शन रिक्वायरमेंट्स हैं या ये डोमेन कंस्ट्रेंट्स हैं। इसी तरह बाज़ जगहों पर एक ही फ़िक्रे में या एक रिक्वायरमेंट की जगह पर मल्टीपल रिक्वायरमेंट्स को इकट्ठे लिख दिया जाता है या उनको इकट्ठा डॉक्यूमेंट कर दिया जाता है, और हालांकि उनको अलग अलग डॉक्यूमेंट करना चाहिए ताकि ना सिर्फ उनका ट्रैक रखा जा सके, हमें पता लगे कि वो इम्प्लीमेंट हुई हैं, उनका रैशनल कहाँ से आ रहा है, उनकी असल ज़रूरत जो है वो क्यों है, और ये कि फिर जब वो इम्प्लीमेंट हों तो हम ये कह सकते हैं कॉन्फिडेंस के साथ कि ये रिक्वायरमेंट्स सॉफ्टवेयर में इम्प्लीमेंट हो गई हैं। अगर वो कई रिक्वायरमेंट्स एक ही रिक्वायरमेंट्स का हिस्सा बन जाएं तो उनके ऊपर जब हम पॉजिटिवली ये नहीं कह सकते कि ये रिक्वायरमेंट जो है ये इम्प्लीमेंट हो गई है। तो रिक्वायरमेंट्स को जितना हम क्लियरली, कंसिस्टेंटली और कंप्लीटली स्पेसिफाई करेंगे, डॉक्यूमेंट करेंगे, उतना मिस इंटरप्रिटेशन का चांस कम है, उतना ही चांस है कि ज़्यादा चांस है कि कस्टमर के लिए एक अच्छी प्रोडक्ट डेवलप होगी। डिज़ाइनर और डेवलपर्स के लिए एक अच्छी गाइडलाइंस आप प्रोवाइड करेंगे, उनके लिए एक अच्छा फ्रेमवर्क बनाएंगे, देंगे, जिसको वो आर्किटेक्चर बना सकते हैं, जिसका वो फिर बाद में डिज़ाइन बना सकते हैं, और एक अच्छी प्रोडक्ट की सूरत में रिक्वायरमेंट्स जो हैं वो मुंतज होंगी। लेकिन अगर इन प्रॉब्लम्स को हम एड्रेस ना करें और कम्युनिकेशन के जो इश्यूज़ हैं उनको हम एड्रेस ना करें, तो क्या नतीजा होगा कि मिस इंटरप्रिटेशन होगी, कन्फ्यूजन होगी, इनकन्सिस्टेंसी होगी, इनकम्प्लीटनेस होगी रिक्वायरमेंट्स के दरमियान, और जो प्रोडक्ट है वो पुअर क्वालिटी की होगी, कस्टमर अनहैप्पी होगा, और नतीजा ये निकलेगा कि जो डेवलपर ऑर्गेनाइजेशन है उसके पास आइंदा के लिए बिज़नेस अपॉर्चुनिटीज़ कम होंगी, उसके जो एम्प्लॉयज़ हैं वो अच्छा मोरल उनका नहीं होगा, और सॉफ्टवेयर की जो डेवलपमेंट का मकसद है वो हमें हासिल नहीं हो सकेगा। तो अगर इस लेक्चर को मैं इस तरह कंक्लूड करूं कि रिक्वायरमेंट्स आर रॉन्ग, systems are late, systems are unreliable, and they don't meet the customer's needs. This results in enormous loss of time, revenue, market share, and trust of the customers. And as professionals, it is very important to win the trust of customers. अगर मैं आज के सारे लेक्चर को रिकैप करूं तो मैं ये कहूँगा कि आज हमने रिक्वायरमेंट्स का एक पर्सपेक्टिव जो कि पहले व्यूज़ से मुख्तलिफ था वो देखा। हमने रिक्वायरमेंट्स को कस्टमर या यूज़र के पर्सपेक्टिव से डिस्कस किया। हमने रिक्वायरमेंट्स को कॉन्ट्रैक्ट या सिस्टम के पर्सपेक्टिव से देखा। फिर आखिर पर हमने कुछ डिस्कशन की कि रिक्वायरमेंट्स के साथ कौन सी प्रॉब्लम्स एसोसिएटेड हैं और उनको हल करने के लिए हमें क्या करना चाहिए। नंबर 1, हमें कम्युनिकेशंस को बेहतर करना चाहिए, हमें डोमेन की इंफॉर्मेशन हासिल करनी चाहिए और रिक्वायरमेंट्स को इस तरह डॉक्यूमेंट करना चाहिए कि उससे एक कंसिस्टेंट एंड कंप्लीट सेट डेवलप हो ताकि डिज़ाइनर्स और डेवलपर्स इसको एक अच्छी प्रोडक्ट की सूरत में कस्टमर को वापस दें। आइंदा हम क्या पढ़ेंगे, ये आज तक के जो लेक्चर्स हैं इसके ऊपर बेस करेगा। आई होप एंड आई एनकरेज ऑल द स्टूडेंट्स to study, and so that when we meet next time they have developed a foundation so that we can take this course to a new level of understanding and so that we can achieve the goals set out for this course. With that, I take leave of you. Thank you very much and see you next time.